All right, so this is the example that I skipped in class today because we're running out of time. I just wanted you to have a chance to see what you do when you're dealing with rational functions. Also, what you would do if you had functions where there was a value of x in more than one location. So we're going to take a look at example number 8 together. So f of x is 7x over 2x minus 9, and the inverse is what we're looking for. So just like we did in class, you're going to switch x and y. So this is going to now say x equals, and then you have 7y over 2y minus 9. Okay, so the problem is that you can't directly solve for y when one's in the numerator and the other's in the denominator. You have to have them both either in the numerator, or I guess you might be able to do something a little bit different if they're both in the denominator. But this idea of one on top and one on bottom is not working for us. So we're going to cross multiply, or we're going to multiply this 2y minus 9 over to the other side of the equation. So this is 2y minus 9 times x equals 7y. And we're going to distribute the x through. Okay, so I have 2xy minus 9x equals 7y. So what I want you to notice is that there's still a y in two locations, and now they're separated by the equal sign. Also not good. I need them on the same side. So I'm going to move the 7y over to the side with the 2xy. And moving it involves subtraction since it's currently positive on the right-hand side. And then the 9x doesn't need to be there because it doesn't have a y in it, so I'll move it as well. And you could have moved both of those in the same step if you feel comfortable doing that. Okay, so now I have 2xy minus 7y equals 9x. So is it true that you still have two y's? Yes, it is. But what we have learned when we're dealing with values like we see on the left-hand side is that if you have a common factor, you can factor it out. So in fact, I do have a common factor. It's y. So if I take the y out, I have a 2x minus 7 that is left. But the 2x minus 7 is still multiplied by the y, and so we undo multiplication, of course, with division. So now I end up with y equals 9x over 2x minus 7. Okay, and notationally, I will write that as f inverse of x equals 9x over 2x minus, minus 7. On this particular one, it doesn't say anything about domain. However, if we were working with what is the domain in this situation, of course, you can't have a 0 in the denominator, and so you would look for where that denominator equals 0 and so forth.